Okay, here we are. Sorry for the noise. They're holding an event on my floor for once. Usually it's super quiet. Anyway, let's get started. But first, I'm just gonna check that this stream is actually up because I haven't ever done this before. Yeah, there it is. Let me just save this. Well, share this video. I was just gonna post this to my Insta real quick. That's fine, I'll do it another time. Okay. Let's get started then. So first up, what we're gonna do is we're going to work on, well, figure out the desaturation for differential drives. For differential drive. Yeah, differential swerve drive. Sorry. Hold on. Damn, I guess I'm just gonna leak my school email address. I guess that's fine. What's the worst that could happen? Yeah, so I like to work on like my iPad when I do stuff like this, because, well, if I just do it on a piece of paper, it's hard to actually keep track of, and if I do it on iPad, I can like label it and it's there forever, and also I can look at what I'm writing on my desktop or laptop. All right. So this is swerve drive. Hold on. Dark Reader is messing with this. Swerve drive desaturation. Alright, I was just gonna get the chat open here. Okay, so let's look what we have. So it's differential swerve. Sorry, differential swerve. So basically, we've got two gears like this, and they're beveled. You go one gear in the middle here, and basically when these two bevel gears, top and bottom, rotate the same way, like clockwise, the wheel of the module will rotate to face a different heading, and if those plates move in opposite directions, then it turns the wheel so the module will move. And the advantage of this drivetrain is that you don't have like one motor for turning and one motor for drive, like what they'll have in FRC. Instead, they can use both motors for either turning or motion, so movements, and it's just the most efficient use of motors. So differential swerve. So first up, let's consider the kinematics real quick. Oops. So if you consider one of those top or bottom gears here, right? It has a diameter, or I'm just going to use the radius for now because it's just easier. Radius. And then we have another bevel gear that's 90 degrees to this. So, and this one also has a radius. So we can find the gear ratio by dividing the radius of the small gear divided by the radius. Actually, no, I got this the wrong way around, sorry. Radius of the big wheel divided by the radius of the small wheel. So if we, hold on, let me think about this. It's been a long day, my brain is no longer braining. Alright, let's just work with this and hope it's right. We'll find out if it's not right soon enough. So this is our gear ratio. And let's see, we also have, but we have two of these. So we have two of the big gears. And each gear has its own motor. And basically, the problem we have to solve is that we have to desaturate these. Desaturate motors. Now, what does desaturate mean? Well, consider the following. So you have 4 modules. This one needs to move at 120% speed. This one needs to move at 80% speed. This one needs to move at 80% speed. And this one needs to move at 130% speed. Now, of course, we cannot move the modules at greater than 100% speed. So we have to scale each one of these modules so that the maximum output by any one module does not exceed 100%. So an easy way to do that is to check, okay, the maximum we have here is 130, right? So what we'll do is take 130 divided by 100. That'll give us 1.3. Or actually, we'll do the opposite way. We'll do 100 divided by 130. And that's going to give us something like 66%. Or something like that. Hold on, let me actually check this. No, I was completely wrong. It's 77%. or just 7.7. Nope, I'm still wrong, 0.77. So then we take this multiple here, oh sorry, this scalar here, and we multiply it by each of these. So we'll do 0.77 multiplied by this, 0.77 multiplied by this, 0.77 multiplied by this, and 0.77 multiplied by this. And then the outputs will not exceed 100%. Now just keep in mind here that even though we have two modules here that exceed 100%, we use this one, we use the 130% because that's the greatest one that exceeds. So yeah. However, it's not quite that simple. See, because differential swerve drive uses the same two motors for angling as actual motion. So we'll have to scale the, actually hold on. Okay, what I think we can do is we'll take a look at both motors for each module. And we'll just look at which one exceeds by the most. So let's say this one's 130%, this is our maximum. We'll just multiply everything. Oh, sorry, we'll just multiply the voltages for every single motor by, let's do 100 divided by 130. But I don't know if this would work, because if we do something like, if we have something like 70, like 7 volts, the top motor, and 0 volts for the bottom motor, what'll end up happening is we'll do 7 multiplied by 0.77 and 0 multiplied by 0.77. So this bottom one, this bottom one here will just stay 0. And this top one here will, it's gonna be something like 5. I think. I have no idea. So I mean, let's just try it and see what happens. I'm not familiar enough with the model yet where I can immediately know if this is going to be a problem or not. Let me just scroll down here. Okay, so our solution. Find absolute value of, actually hold on, the chat just disappeared. Okay, there we go. Find the absolute value of the voltage of the largest voltage, sorry, of the voltage with the greatest magnitude, we'll say, because voltage could be positive or negative. Find the absolute value of the voltage with the greatest magnitude divided by the maximum theoretical voltage. And then we multiply all output voltages by the quotient. Okay, now I don't actually have a way to test this because unfortunately I do not have the robot in my room. Of course I don't. And I haven't figured out if Queen has set up like an actual proper simulator for it. I know they have a model for it, but I don't know if they actually have like a proper simulation like software for it. If they don't, I guess that's what we'll be working on next. So is the important part that the ratio? Like the ratio we found here? Yeah, see, I don't think this ratio actually mattered in the end, so I just kind of left it. But the important part of the solution here is the ratio between the of the voltage with the greatest magnitude. So if you request the motor to go like 130% or like 15 volts when it's like 12 volts max, we'll do 12 volts, which is the maximum theoretical voltage, divided by like 15 volts, which is the requested voltage, and that'll give us the quotient. And then we'll multiply that quotient by every requested voltage output. So we'll do like if we just draw over here, we'll have like top and bottom motors. We'll do like 12 volts multiplied by 0.77 and like 15 volts multiplied by 0.77, and this will desaturate the motor output. Oh wait, hold on, I didn't see the whole part. I didn't see your whole message. Hold on. Sorry, the display was being a bit weird. Like the ratio between the magnitudes of each wheel's driving vector. Yes. Yeah, that's the important part. Basically, we want to scale the linear and angular velocities of each wheel by the same amount. So if we have our drivetrain here and we have a lateral velocity vector of like 10 and 10, and an angular velocity vector of, let's say, sorry, not an angular velocity vector, it's just angular velocity, and we have angular velocity of like 0.5, but we need to desaturate it. We want them both to be scaled by the same amount. So then what will end up happening is something like this, where the lateral velocity vector is something like 7.7, and my brain's not burning, so I'm just gonna change this to 1 just so it makes it easier, and then angular velocity will be something like 0.7. So it's basically gonna move the same way, just slower. Otherwise, what would happen if we don't do this is the angular velocity and lateral position vectors is just going to be all off, and we don't know what exactly it's going to be. By desaturating the motors, we know at least how it's going to behave, and it's going to behave in a way that's much more, well, it's a lot easier to deal with. Okay, well, I guess we have found a solution. Honestly, I thought it was going to be harder. I thought like we're going to have to do something silly with like actual gear ratios here. But now that I actually think about it, we don't actually need to do that. So let's go on to lemlib stuff then. So what we'll be working on is hardware abstractions, and if we finish that, we'll probably go on to we'll probably go on to abstract controllers. Okay. So I actually have like a 27-inch monitor, so I usually have like the text much smaller than this, but I've made it bigger so people on the stream can see it easier. And also, if people have just bad internet and viewing this at like 480p, they can hopefully see what the text says. Okay, let's move on to... Actually, this is a completely different repo, I forgot. Hold on, let me just get the chat nice and like centered. Or at least just... Are you kidding me? Is it actually just gonna be this much of a pain to work with? Okay. Okay, this should be fine. Alright, hold on while my residence Wi-Fi tries its best to download the super small Git repo. I don't know if the other residences at Queens has Wi-Fi that is this bad, but considering how bad my residence is compared to the other ones at Queens, it's entirely possible that theirs is completely fine. This is actually hilariously bad. Okay. I'm just gonna clone it with a command line because we can actually see like proper progress to it. I don't remember Windows terminal commands. Okay. I'll just do it with the file explorer. Oh, it's already gone. Okay. Holy moly, we have a whole 40 kilobytes per second. Incredible speed, incredible. Right, hold on, I'm just gonna go fill up my water bottle. I'll be right back. Alright, I'm back. Well, let's see how many viewers we have now. Oh, we have a whole 2 viewers. Okay. Alright, so looks like it's cloned now. Alright, so last time I worked on this, I figured out that we can actually have motor encoder objects be completely separate from motor objects. I thought that like encoder objects could actually have overlapping features with like motor stuff. So if you had access to either one of them, they could mess with the other. But that turns out not to be the case. So turns out that motors, you can get the raw position of motors, so like the actual encoder ticks from them, but those encoder ticks cannot be changed software-wise. So you can't set those encoder ticks to be something different. You can set like you can set the reported like motor angle to whatever you want, but you cannot set the raw motor ticks. So basically what that means is, even if you have 2 different encoder objects and you set one to be a different angle, the other one will be unaffected even though they're actually operating on the same motor. And this is nice because then we can actually have a separate motor encoder and motor object, and it just makes stuff simpler and more containerized, if you know what I mean. Yeah, so let's get working on that. So we have our header here for the abstract encoder class. Let's just minimize all this so we can see what's up. And let's open the source. Okay, we want to make a new header for motor encoders. Forgot the C++ syntax for a second. Alright, why is it not happy? Oh, that would be why. Okay, and now it's, yep, that's not gonna be happy because of that one right there. That's fine though. Okay. Now, of course, we're actually going to define all of these because we can't have it be an abstract class because it's going to be a full implementation. So visual int is connected, get angle, and set angle. I really like, I spent a lot of time and as well as time collaborating with others to make this class here. So we don't want to go like super overboard with abstractions and object-oriented stuff. Any abstractions that we do have to make sense, and they have to be super simple. That's basically the rules we have for Lemon v0.6. And I think this is pretty, well, not a brag, but I think this is pretty much the optimal way of how we can do it. I guess technically we could have it like stuff from like encoder derived from like a device class, but until I can think of a reason why we should do that, except that we can just have this like is connected for that device class, and then have like chained, sorry, and then have this class like implement from encoder and device, or have the encoder implement device. I think it's just simpler just to do this. Alright, now let's create the source file. Alright. Oops. And you renew my student details on GitHub so I can get GitHub Copilot again. Writing stuff without it is just so much slower. In my experience, GitHub Copilot is like really bad at actually like implementing logic from like comments and stuff, but it's really good at just taking the like repetitive stuff out of your workflow. So it still makes you faster. It's basically just fancy autocomplete. Alright, virtual int is connected, okay. Right. Wait, hold on. Do we not have auto formatting on? I don't think I do. Usually what I do is I just have it set up so it formats the file every time I save, because that way it's impossible for me to commit code that is not formatted properly. Okay, motor encoder. Sorry, motor encoder is connected. Okay, let's pull up the pros API docs real quick. Actually, no, I remember it now. We don't need to do that. Okay, so I guess what we have to do here is we have to make ourselves a private motor member, and we also need to make a constructor for this. And do we make this const? I think we can make this const, yeah. Let me see. I think we can get away with just giving it a port for the constructor. Well, I don't know what we do in the other classes. Oh, we don't even use port. We just take the pros object. Okay, that works. What's it complaining? Ah, right. Initializer list, go. We'll see if this actually links. I don't know if it's gonna complain in the linker that it's a deleted copy construct that it's a deleted copy constructor, or if it'll do so before linking. So if it does it during a linking, it's not gonna, the linter is not gonna be able to tell me that this is wrong. Actually, let's just compile it and see what happens. So let's see what's up. Okay, undefined reference to right. Okay. Well, anyways, pro tip: if instead of pros make you do make quick dash j, it'll still do like the regular pros build stuff. Except what it'll do is it'll actually compile all the files in parallel. So it'll use multiple CPU threads and it's like 5 times faster. I don't really see it go faster like with more cores I have, because like I tried this on my friend's 32 core machine and it was like the same time for compiling, so I think there's still some single threaded stuff going on that's limiting the build times. Anyways, it's still stupid fast. Okay, it's connected. I think it is installed. No. As type const. Why is the is installed function not marked const? Okay, I guess you cannot have a const motor because apparently they have to do write operations to check if the motor is actually on a port or not. Okay, install. Does this return anything with Erno? Nope. So I still have to like go look at like what's standard practice here, because we use Erno for error handling. I'll explain why we use Erno in a second, but because we use Erno for error handling, stuff that usually return bool, we make return int so we can return that a sentinel value. Yeah, so the reason we use Erno is because we want to have error handling, but I know that not a single one of our users are actually going to check for errors. So instead of if we use exceptions, then it's going to crash whatever thread it is on if like the motor disconnects, and that's not good because, like I said, none of our users are going to check for errors. And the other thing we tried was std expected. Std expected would have been nice if it actually forced users to check the output value of it, but if they don't check what type the output value is, it also crashes actually no, it doesn't even crash the main thread, it crashes the entire program, which I didn't even know, which has never happened to me in 4 years. So that's why we use Erno. Do I like it? Absolutely not. Is it necessary? Yes. Okay, we can just have it do this. We return the output. Yeah. There we go. Get angle. Okay, this one's gonna be fun. Alright, let me open up I'm gonna see if we still have that implemented in our regular motor implementation. Hold on. Yes, we do. All right. So actually no, we don't need to consider the cartridge because we always use the, actually no, we do have to consider the cartridge. Oh, this is gonna be fun. Okay. What am I doing? Right. It wants the, we need to give it like the get cartridge stuff. Do we hide this from the user? No, we do not. Oh, I do not have that extension. Alright, let's try that again. Okay, well, I'll have to reload the web view. Actually, no, that's not red. That's not web view. So. See, this bug has been annoying me for like months now, but I still haven't opened a report on it. Basically, it'll always show the welcome screen. Doesn't matter if this is ticked or not. Alright, let's do the return values. Damn, I was like, for a second I was like, this does not look like monospace. See, I usually program with monospace, but this is a fresh install, so I haven't installed that yet. Actually, let's do that right now. So the front I like is GitHub's monospace. Basically it's monospace, but it has texture healing, so it'll make some characters fatter or thinner depending on the characters next to it. It's pretty damn cool. Like you can see that right here. Like look at the size of this M here. Look at the size of this M here. The M expands because it has space to do so, but it's still monospace. And it also has a Lego church, which is pretty fun. Okay. Installation. Oh, that's pretty silly. Okay. Let's do that real quick. Oops, looks like someone has got, looks like someone, looks like someone made the zip on macOS. Yep, someone definitely made the zip on macOS. Okay, fonts, yes. Oh, they haven't got it to chocolate. I thought they got it on chocolate, and I got excited for a second. Drag it, okay. Oh, what? Does not appear to be a valid. What? What? What nonsense is this? Hold on. Alright, never mind. I'll just do it later. I need a code spell checker. Oh, I can hear a fire truck. Looks like someone on the main campus decided to pull the fire alarm again. Huh, I did spell this right. Okay, cool. Or no, it just doesn't work. Okay. No, it's there. Okay. If it's bad, I'll figure it. Someone will yell at me. Okay. Now we have to write example code. Oh no, it is working. Oh, it is spelled right? Okay, good. I used to be really good at spelling, but then it's just like a flip of a switch. One day I just got bad at spelling. I guess because now I have tools to tell me if I spelled it right or not. I just have this feeling if it's not spelled right or wrong, but the feeling doesn't mean it's right or wrong. It's horrible. All right. Before someone says it, I want to learn Vim key binding so I can type like code faster, but usually coding is not, when I code, it's not brainless slop like this. It's usually actually interesting stuff that you have to think about. So I usually spend 95% of my time actually thinking before I code, but in this case there's no thinking, it's just code, so I'm slow. Actually, we have one more case, right? And also this needs to be all caps. Yeah, I got it. Wait, hold on, what? Yeah, it's supposed to be capitalized. I couldn't find an extension that actually, like, an extension to CLangD that'll run like checking for example code and doc and like comments and stuff. It's on my list of things to do, but my list of things to do is very long and it only gets longer. So yeah. Okay, let's check. Alright, this is how I do it. And do I actually put that before? Yeah. You know what? That's probably smarter. I think I'll do it next time. Why didn't I? See, sometimes I just like marvel at my own stupidity for not thinking of stuff like that. Yeah, well, the order asterisk is okay. I mean, it's basically just spacebar asterisk, no, spacebar asterisk down left, spacebar asterisk down left. Yeah, it's a lot easier. It's a lot less annoying than figuring, oh, blue is not capitalized, and then have someone yell at me, making an issue on GitHub saying, oh, it's not capitalized, and I'm complaining, why doesn't the code work? Okay, what was I about to do? Oh, yes, right. No stuff. Alright, I know it'll do Dev. Oh, hold on. What's this complaining about? Right. Actually, we should be able to mark this const. I wonder if cline is better with this stuff or not. I don't know. If Rocky was here, he'd be able to tell us. He's the only one I know who uses cline. Alright, okay, yeah, we need this. Get absolute counts. Okay, I'm just gonna yoink that from the last motor implementation. Actually, no, wait, hold on. We don't need to do all this stuff because we want to get the actual row position of the encoder counts. We don't need all that. Oh, you switched too? Oh, okay. And so my CLangD never really gives me problems. I like CLangD. It's fast as hell. Don't tell me it actually wants to Bro. It actually doesn't. It just has this as equals null as a default. I have to actually give it null. Are you serious? Damn. Hold on, let me just check if this actually checks so it doesn't like do null pointer shenanigans. Alright, yeah, if it's null, it's fine. See, what? Why can't they just do this? It would have been a problem solved. I guess they just copied it over from the C stuff and didn't bother to actually change it. Because I don't think you can do default parameters with C. Which is kind of weird. I don't know if that would be actually probably would be a breaking change. Some odd obscure C thing. Alright, actually we're gonna have to get rid of all this logic anyway. Because the row encoder counts are not scaled by the cartridge. So we don't actually need this here. Womp womp. All that work for nothing. Let's go. Okay, so we need to get the row position in encoder counts. The annoying thing about order formatting is like whenever I write something like this, like a line of code, I'll automatically just do Control S and then it formats it and puts it on one line, and then I have to like expand it again. Despite months of using this, I still haven't gotten used to it. Alright, encoder count, and there are 3,600 counts in a rotation. 3,600 counts in a rotation. Okay, that gives us our row angle in unitized row angle. Okay, but now we need another private member variable. So because we're not writing anything to the config of the encoder, we're just using the row position. We have to keep track of the offset ourselves. Now this is actually advantageous because, well, as I explained before, we can have multiple encoder objects operating on the same physical motor, but they're independent of each other. We can set one encoder object to a different angle and the rest are not affected. And also, if we don't use like the hardware angle set, if we use the angle hardware set, it would like round the requested angle to like the nearest multiple of whatever the ticks are. Sorry, for whatever the ticks multiplied by the cartridge is. And so you could actually have, if you try to reset the encoders, they might not actually reset to exactly 0. But with floating point offset, it'll be pretty much exactly 0. So angle offset, okay. Alright, then all we need to do is do raw angle plus offset. That's our return value. And before we do anything, we have to do error checking. If encoder count equals int max, return. This is angles, so we have to do infinity. We don't, for any of you watching asking, why aren't you setting erno? It's because this function here will set erno for us. And since this would be operating on the same thread, we don't have to set erno again. Okay, there's our gets angle. Let me just specify the erno stuff. I'm just gonna copy paste whatever we have for whatever this is for the other stuff, so it's nice and consistent. Let me check that dev's the only thing it can. Oh no, we also actually we don't have to ever have to worry about e overflow here because basically, well, I don't like how pros did their, well, I don't like that pros have their motors and motor groups inherit from the same abstract motor, because it means I have to do dumb stuff like giving it a, like potentially giving it an index here. Giving it an index here, even though there's only a single motor in that object, because they need this for the motor groups. But anyways, we're not gonna do anything about that because we'd actually have to do like this to have it return that value of erno, and of course we're not gonna do that, and so we're not gonna bother with documenting that, because even if it does happen, there's nothing the user can do about it. I'll just confuse them like, what's the index? It's not a parameter. Okay. So that gives us our get angle. Now we need our set angle, yes. Okay, so let's do some quick maths here. Our output is equal to row plus offset. So we are given the output here, it's angle. So we're gonna rewrite it with that variable's name. angle equals row plus offset. And we can find the row, like we can isolate row, then just do angle, sorry, we know row, so angle minus row is equal to offset. There we go. Actually, I'm just gonna name this something else. Actually, no, encoder counts, it's fine. So then we just do, actually, I'm just gonna convert this to an angle directly. Actually, no, that's gonna be a bit, the line's gonna be a bit long if we do that. Let's just do error tracking real quick. And then we just set the angle. Oh, there we go. I'm just gonna move this comment to the bottom. Actually, no, I'll just leave it at the top there. Actually, no, we don't even need this comment at all. Actually, I'm just gonna document the encoder counts thing in over here at the top of the class. I really need to get this keys. I don't make such a racket. They're so loud. I don't know how I didn't find it annoying before. You guys probably hear it on the mic. Alrighty. So I've got set angle. All this does is set the offset. And yeah, that's that. I guess what we have to do now is change this so it's no longer using like the example code from the abstract, from the like the implementation, the encoder interface. Yes, I know it's not actually an interface. I know interface is a Java term, but like this is the equivalent to an interface in C++. It's just a purely abstract class. Okay, yeah, right. Oh, we also have to document the constructor. Right. Okay, yeah. Constructor time. I just realized I should probably explain why this is const. So, even though the motor, we're not taking a reference to a motor, we still mark this const because the motor object actually contains the port of the motor. So you can actually copy a motor object, and now those two motor objects are linked because they're referring to the same actual physical motor. So we mark it const anyways to show the user, okay, we're not gonna like set any configuration stuff on the motor. And yeah, this is the motor encoder object. I guess we do not need this. Actually, no. Nope, we do need that. Rats. Now this is particularly annoying because now we have the same enum in motor encoder and the regular motor. And I don't know, I think we need it in the regular motor anymore because we separated the encoder from the motor. Yes, that is correct. We do not need the cartridge stuff in the motor in the regular motor class anymore because we're separating them. Motor type and brake mode can stay, but cartridge needs to go. Yes, cartridge, get cartridge. We'll yoink this. Let's just adjust this documentation real quick. Okay, so we actually document the no values before the return values. Okay. Oh, we also need to do the we also need to document the no values here. Damn, documentation can actually be such a pain in the ass if you do it properly. Just dev, right? Yep, just dev. Because we just read from the motor. Like, we could set this const, but we don't because the abstract class is inherited from does not mark it as const. And we do that to give the user more... Actually, no, we couldn't mark this const because, right, we'd have to change this. Sorry, I'm just being stupid. Okay, yeah. Looks good to me. Except that the case is not on the same line here. See, the auto formatter also doesn't format example code. Wait, hold on. I just want to check how many viewers we have. I suspect it's going to be 0 now. We've been streaming for almost an hour and a half. Oh, no, we still have 2 viewers. Okay, yeah, okay, I'm just gonna yoink the get cartridge function from the previous motor implementation as well. Oh, you know what? We're going to have to make a motor encoder group. Yay. Yay. Okay, yeah, we'll remove all the encoder stuff from the previous motor group implementation. Hold on. Get cartridge, we put that underneath the constructor, okay. Okay, nice. Do we do a set cartridge for the motor encoder? No, I don't think we should, because the cartridge won't change during runtime. Okay, let's clean up the previous motor implementation. It's just going to be removing stuff. Constructor stays, move velocity stays, brake stays, set brake mode stays, get brake mode stays, is connected can stay. We want to override it now though. Get angle has to go. Set angle also has to go. Also, we don't have to inherit from the encoder class anymore. Okay, we do have to include the unit stuff. Connected can stay, get type stays, is reverse stays, set reverse stays, get port stays. This can go. Alright, this gets eaten rather, and this gets eaten. Now this is much nicer. Okay, and now we get to figure out the encoder groups, or just the motor encoder group. No, this shouldn't actually be too bad, because we already have all the logic for it in the current motor group implementation. But oh, right. I think it doesn't know what encoder is, because we took it away from this include here. Let me think though. See, I don't think it is necessary. Actually, you know what? No, it is necessary to have a motor encoder group, and the reason I say it's necessary is because we use motor groups handle will handle it if like a motor disconnects from the group during runtime, it's not going to throw infinity unless all the motors are bad. So we should do the same for our encoder group here. Motor encoder group. This is so silly, but it... I don't know how I missed this, but there's no pragma once in this file. Okay, move stays, move velocity stays. Oh, actually, I want to check if this one pros feature got merged in. One that I think Ayan opened. It's to do with the voltage for 5.5 watt motors. Because right now, the 5.5 watt motors only go up to like 8 volts, while the 11 watt motors go up to 11 watts. And that's a problem because when we use motor.move in a motor group, it would mean that the 5.5 watt motors will work a lot harder because they're trying to move faster than the rest of the group. And this can also cause other undesirable behavior. So what we have to do in our motor groups is we have to figure out whether a motor is 5.5 watt or 11 watt motor. But Vex in all their genius has decided not to add that as a Vex SDK function, even though added as a Vex code function. So we have to figure out ourselves how to do that. Fun fact: there were two possible ways we could do it. We could try to check the motor flags by directly interacting with the Vex SDK. But because the pros version of the Vex SDK doesn't expose that, or just doesn't have that API, we actually have to interact with we can't just forward declare the API that's not exposed. We actually had to interact with the Vex SDK by calling its address in memory, which would have been could have caused problems because it might break between Vex OS updates. And of course, they'll never tell us about stuff like that because they don't even put anything on the changelog anyway. There's no way they're going to document undocumented features or change it. Document undocumented stuff. Sorry. Pros, right? Oh, they get a new version of holy cow, they actually didn't think they'd get a new version of the SDK until like late season. But I guess Vex actually did their job and honored their contract and got them the new version of the SDK. It took them long enough, that's for sure. Holy cow. Differentiated move. Oh yeah, it hasn't been merged yet, so we're good to go. This can this can get eaten. This can get eaten. This can get eaten. get size, that stays, add motor stays, this also stays, this also stays, this stays, configure motor. Oh no. See, when a motor is added to a motor group, some things need to change. That some configuration stuff needs to happen for that motor. Its brake mode needs to be set the same as the other motor, so it's not like one motor braking everything else in the motor group, because that's going to cause that motor to overheat a lot. And also the angle of the motor needs to be set so that it doesn't change the angle reported by the motor group, because otherwise that could mess up odometry if you're using internal motor encoders. So I guess we're gonna have to change that function so it doesn't do the angle stuff anymore. But what it does mean is that we're going to need since the motor encoder objects are separated from the motors, damn. See, what the API that wants to have is that you just pass a pointer to a motor group, to like the chassis constructor, and then if you want to add or remove a motor because like you have a PTO, then you can do that. You can just call add motor or remove motor on your own copy of the, on the motor group that has a pointer to it, right? But you'll still be able to do that. However, if you're using internal motor encoders for odometry, yeah, that's not gonna work because we'll have to update the motors in that group as well. Sorry, the motor encoder group as well. So that would mean we need functions in the chassis class to like add motor left group, remove motor left group. Damn, this is actually annoying, because now that means we can't actually separate the motor encoder group from the regular motor group because of that. I guess technically this is one of those things where it would be the correct the cleaner design choice, the correct design choice, if you would, because there are stuff that should be separate, right? But we have to remember here that our user base barely knows how to program. Or even if they do know how to program, we still need to keep the API as simple as possible for them. Yeah, this is the hard thing about writing this library. You're not writing it for software developers. You're not writing for university students. You're writing it for high schoolers who only been programming for a couple of months. This is their first language, right? So it's super important that we keep the API simple. And sometimes, in situations like these, where we have to make objectively bad design choices to keep the API simpler, we'll make objectively bad design choices on purpose, and we know there are bad decisions. So I guess what I'm saying is the past hour and 15 minutes is just an hour and 15 minutes that I took to figure out that, yep, this is just a bunch of waste of time. Let's freaking go. Okay. I'm probably gonna end the stream here. It's getting, well, it's not late, but like, I feel tired. And well, at least we figured out that we can't actually separate the motor encoders from the regular motors because of API simplicity stuff. And I also know what I'm going to improve for next stream. I'm actually going to figure out if I can make Windows pin a window, so I don't have, so I can have the stream chat up here, floating in front of VS Code, so I can have a little bit more code, like space. Because when I do split view editing, it can get a bit cramped otherwise. Also, I didn't want to figure out if I should turn on my webcam or not for next time. Okay. Well, thank you everybody, and I'll see you next time.